Hi guys, welcome back to Simple TV Math Explain. So in our previous video, I explained basic properties of the circle. So in today's video, we are going to answer a question based on the theorems that I explained in the previous video. So if you haven't watched our previous video, down below here, there is a link. Watch our previous video, then you are going to be able to understand fully and clearly what is happening here. So I have a question today which says, in the diagram below, A, B, C, D is a cyclic quadrilateral in a circle with center O. Angle A, B, D equal to 40 degrees. Calculate the sizes of angle B, angle D, BC. So I've been told to calculate the size of angle at D, B, C. So I've been told to calculate the size of this angle here. This angle that you are seeing here, this is the angle that we have been told to calculate first. So I'm going to say our first question, question A, we have been told to calculate angle DBC. This angle here, angle B. So how are we going to calculate this angle B? So remember, one of the theorems I explained that angles formed in the same segment of a circle are equal. Angles formed in the same segment of the circle are equal. So CD, this distance here, it is called an arc, and this line here, it is called a chord, and this part here, it is what is called a segment. So the angles that is formed in the same segment are what are equal. So in this case, we have two right triangles. We have C, A, and D. We also have angle D, B, and C, and we have been told to calculate what angle B. So the angle that is formed here, it's equal to the angle that is formed here. That's what I explained in the previous video. So please do so. Watch the video first, and then come and watch this video. So we are going to say angle C A D is equal to angle D B C. Basically, that's what that theorem was trying to explain. So if this angle CAD it's 180 degrees. Also this angle BDBC, it's going to be equal to what? 18. It's going to be equal to what? 18 degrees. So therefore, angle DBC equal to what? 18 degrees. So we have answered our first part of the question for today. So let us look at the second part of the question. The second part says, calculate angle ACD. We have been told to calculate angle at ACD. We have been told to calculate this angle here. This is the angle here that we have been told to calculate. Angle what? We have been told to calculate what? Angle C. So in this case also, in order to calculate angle C, we are going to say, this is our B part here. We are going to say what? Angle BDC is equal to angle, we are going to say angle A, we are going to say angle AC. Okay, let me just write it again. We are going to say, this is our B part, right? So we are going to say angle ACD, it's equal to angle ABD. And in this, so this angle here, angle ACD, this angle here that we are calculating here, it's equal to what? It's equal to angle ABD. So this angle ACD, it's equal to angle ABC. So here, the distance from this point to this point, it is called an arc, and the distance from A to D, this straight line, it is called what? A chord, and this area also, it is called what? A segment. And we know that angles in the same segment are what? Are equal. That simply means this angle A, B, D, it's equal to angle A, C, D, because we have two right triangles that lies in the what? In the same chord here. And one of the theories that we explained on our previous video is that angles in the same chord are equal. So you're going to say, therefore, angle A, C, D equal to 40 degrees. So this angle here, it's equal to what? 40 degrees, because angles in the same segment of the circle are equal. So let us move on to our part C of the question. Part C of the question says, calculate the size of angle BDC. BDC. We have been told to calculate the size of which angle? We have been told to calculate the size of this angle here that you are seeing. So how are you going to calculate this angle D here? So in order to calculate angle BDC, this is our part C. So in order to calculate angle BDC, it's equal to this angle BDC, it's equal to angle BAC. So this angle that we have been given, angle BDC, this angle here, it's equal to angle BAC. Here, BC, this straight line here, it is called a chord, and BC, this is an arc. It's a part of the circumference, and this area here, it is what we call a segment. And one of the theorems that we talk, its angles formed in the same segment of the circle are equal. So angle BAC, it's equal to angle BDC. This is what I have written here. So I'm going to say, therefore, angle BDC equal to 51 degree. So this angle here is 51 degree, because this is our segment, and we have right angle triangle, which is BAC and BDC, and the theory explains that angles formed in the same segment of the circle are what? Are equal. So that's why I've emphasized that you watch the previous video about the basic explanation on circle theorem before you come watching this video. So we have our D question, our D part. Our D part says, calculate angle ACB. Calculate angle. We have been told to calculate angle ACB. So we have been told to calculate this angle here, angle what? Angle C. So how are we going to calculate this angle C? So this is our part D. How are we going to calculate this angle C? So you can see that ACB, this one, it's a right angled triangle in the circle. So we always know that a right angled triangle, adding up all its three sides, it's going to give us what? 360 degrees. 360 degrees. So in order to find, we have a right angled triangle. So this right angled triangle, you know that adding up all its three sides of right angled triangle, it gives us what? 180 degrees. So when you add three sides of right angled triangle, or three angles in the right angled triangle, you should be able to get what? 180 degrees. So what are we going to do here? So we are going to say angle ACB plus 18 degree here, this is our 18 degree, plus 40 degree, plus 51 degree equal to 180 degree. So we know that since this it's a right angle triangle, adding up all its three sides, we should be able to get what? 180 degree. And we have been given 18, 40, 51. So when you add up the total sum that you are going to get here, you are going to group the like terms together. So what I'm trying to say is, we are going to say angle A, C, angle A, C, B, angle ACB. After you add this, the total 80 plus 40 plus 51, then you are going to group, you are going to get the number that you have found. It's going to come here, which will be negative what? Negative that number that you have found. Then after you are done that, you are going to subtract the number that you have found here into 180, which is going to give us what? 71 degree. So angle ACB here, it's what? 71 degree. So you can see that if you add 71 degree plus 18 degree plus 40 degree plus 51 degree, you are going to get back your 180 degree, which makes up the right angled triangle. So let us calculate our last question for today, angle ADB. Angle ADB. Angle ADB. We have been told to calculate this angle here, angle D. So how are we going to calculate this angle D? So this is our equation. This is our equation, our last question for today. So how are we going to calculate this angle ADB? So we are going to say angle ADB, it's equal to angle ACB. So this angle ADB, it's equal to angle ACB. Why does this theorem say this? Because AB, this straight line that you are seeing here, it is called a what? A chord. And A coming this side, reaching at this point, B, it is called an arc. And remember the theorem that we explained, that angles formed in the same segment are what? Are equal. So also this part that you are seeing here is a segment. That means the two angles that are formed in the segment are equal. We have two right angled triangles. We have ADC and we also have ACB. So if this angle ACB, it's 71 degree, that means this angle, also angle D here, it's going to be 71 degree, because angles formed in the same segment of the circle are equal. So you're going to say, therefore, angle ADB, it's equal to what? 71 degree. So basically, this is how you answer circle theorem using this angle and circle angle and theorems of the circle. So if you haven't watched our previous video, basic explanation on circle theorem, down below here there is a link. Please watch the video, then come back here and watch this video to get the sense out of it. So if you enjoy the video, guys, don't forget to press a like button, and you can leave your comment in a comment section below so that I can hear your view. But mostly, don't forget to subscribe to this channel and share the video so that others too, they can benefit. Thank you very much.